Assalamu alaikum wa rahmatullahi wa barakatuh. Today we will cover lecture 2 of the software testing. We did in chapter 1, we talk about many different types of testing. And today we are going to talk about more and more and more. In any way, all the tests we are done, no matter what the name of it, if it is unit testing, integration testing, system testing, white box testing, black box testing, user testing, user acceptance testing, regression testing, all these type of testing, they come really in many different stages. Actually, when we build the program, when we build the whole system, at the beginning, we went there and we analyzed it and we took it top down. We start with the context diagram, classes, subclasses, until we get to the function. We wrote the function and the programs, and now we have to test them bottom up. We have to test a unit with a unit to come with a module, module with a module to come with a subsystem, subsystem with a subsystem to come up with a system. Then we test the system, the whole system, which is system testing. Then we go and we do a user acceptance testing or release testing, which is the last testing before we give the project, the system to the user for production use. Well, the stage of testing, according to author here, they saying development testing. Development testing, where the system is tested during development or discover bugs and defects. Release testing, where a separate testing team tests a complete version of the system before it's released to a user, and user testing, where user or potential user of system test the system in their own environment. As we said, it is, it's the problem here, or the different actually probably in the terminology. We develop the program or the function, we test it, we call it unit testing. And from now on, we have integration testing. We integrate unit with unit, module with module, subsystem with subsystem, until we get the system testing, user acceptance testing, then we release it, the last thing. User testing, where user or potential user, this is really user acceptance testing. What really we are doing in the development testing, as we really, the author says here. Development testing include all testing activities that are carried out by the team developing the system, which it is unit testing, component testing, or system testing. Unit testing, it's an individual unit. It's been tested. You as a programmer, you wrote the program, and the software engineer or the analyst give you a specification for the program, and he or she should give you a test cases. You test the program according to the test cases, and then when you've done and everything, it really passed, all the test cases are passed, you give it back to him. Then after that, the component testing, which is the integration testing, start. Your unit, your program, the one you wrote, and somebody else's unit, we test them together, where several individual units are integrated to create composite component. Component testing should focus on testing a component interfaces. Because the unit testing, we test it through each unit is really doing what it's supposed to do, etc. Then the component testing is the interface between. When we are done with the component testing, program and program, unit and unit, module and module, subsystem and subsystem, now we get the whole system. Now one unit, we test it. All the components in a system are integrated, and the system is tested as a whole. Here, actually, when we test the system as a whole, we don't test it for functional. Probably we test it for non-functional requirement to see if the system is safe, if the system is secure, if the system whatever, all the non-functional. Unit testing is the process of testing individual component in isolation by itself. It is a defect testing process. Unit may be an individual function or method within an object class. It's in a class with several attributes and methods, composite component with a defined interface used to access. So the unit, it varies, you know. It could be a small unit or a couple of units together. But actually, we don't want to confuse you here. When we say a unit testing, it is really one unit, one program that is done by the coder, by the programmer. Because you know, you as a programmer, you know about this program you just write. But the integration testing, the relation between two units, two modules, whatever, I think you as a programmer, in your experience, probably you don't know about it. Somebody else, which it is like the software engineer or a special team for testing, probably they know about the system, they know the interfaces between them, and that's why they do the integration testing. Object class testing, we complete test coverage of a class involved, like, you know, a unit testing, like a class testing all operation associated with the object, setting and interrogating all object attributes, exercising the project in all possible states. Inheritance make it more difficult to design object class test as the information to be tested is not localized or whatever. So I tell you, it's, you know, how really we test the unit testing. As we said, you know, the analyst or the software engineer who has to compose the test cases and give it to you. It should cover most of the requirement, relation between the requirement, and as we said, it is a defect testing here. Well, if we look at the weather station class, we see, you know, some of the identifier here, what are the identifier there, and the function. The function they do report weather, report status, power save, remote control, reconfigure, restart, shut down. Of course, you know, we write a test case for each of these, or a sequence of, you know, these, like you report, then probably you reconfigure, then you restart, you shut down, probably you shut down, and then you restart and you shut down to see if really it did work, you know, the shutdown and the restart. And that's, you know, some kind of test cases. Well, as I just mentioned, you know, in the previous slide, we need to define test cases for report weather, calibrate, test, startup, and shutdown. Using state model, identify sequence of state transition, sequence of the state to be tested, and event sequence. Example, we did the shutdown, then we run it, then we shut down to see if really it ran after a shutdown, and then it shut down after run. We configure, then we run, then we test, transmit, running, collecting, running, summarizing, transmitting, running, whatever. In another way, we test like probably all the activities in that unit or in that object. Well, we mentioned one day, I think, you know, in the incremental, we said, you know, automated test. When we have to repeat the test again and again for every increment, whatever, the testing activities, it will become really a time consuming. So whenever possible, I think it is good really to automate the test. Because, I mean, when you write a program, 400, 500 probably statement or so, you need to check all the cyclomatic path with that program. All the paths, you know, it goes, you know, with that program. And this probably, it goes to hundreds or probably or 1,000. And this is really time consuming when you try to do that test case again and again and again. And when you change the program, then you have to do all the test cases again and again. So when it is become really time consuming, I think it's a good idea to automate it. Like, you know, put it in a program and run it automatically. And there are some probably programs or framework or whatever, probably such a JUnit or whatever, I think it, you know, you could use to run the test automatically. Well, like whenever possible, unit testing should be automated so that tests are run and checked without manual intervention. In automated unit testing, you make use of a test automation framework such as JUnit to write and run your program test. Unit testing framework provides generic test cases that you extend to create specific test case. They can then run all of the tests that you have implemented and report, often through some GUI, on the success or of otherwise of the test. And the success of otherwise of the test, that's what. Automated test component, a setup part where you initialize the system with the test case, namely of the input and expected output. You test, you put a test case. A call part, which it is calling that test case, with this parameter, whatever, where you call the object or method to be. An assertion part where you compare the result of the call with expected result. If the assertion evaluate to true, the test has been successful. If false, then it has failed. So automated, it's the same, process. You set up, the test case, you call, and then you find out really the result. Unit test effectiveness. The test cases should show that when used as expected, the component that you are testing does what it's supposed to do. The unit test, it's really more effective. First of all, it is the first step to test the program. And if those test cases done correctly, if the person who put the specification as a software engineer or a system analyst or whatever, he knows fully what that system or what that program is doing, and he covered it with all test cases, it will become really effective one. Effectiveness, you talk here about, as we said, when you test the program against the specification, it is verification. But if that specification is correct and it is what really the user want, it will become validation. So the unit testing, actually it covers two things, which it is verification and validation. If we do the unit testing correct, probably we are not going to have any problem later on in the system, in the user acceptance testing later on. And actually what's happened in the real life, in the unit testing, we bring the customer right away and we do the unit testing and we show them the result to see if there is any defect, if there is any problem. Because if there is a problem, we'll try to find out if the problem is fixable now while the customer is really around us. We don't have to wait for user acceptance testing later on after system testing in order to fix it, because we have to go to block one and do the unit testing, integration testing, system testing, and then user acceptance testing. If there are defects in the component, these should be revealed by test cases and fixed now. This leads to two types of unit testing. First of these should reflect normal operation of a program and should show that the component works as expected. Everything is okay. The other kind of test should be based on testing experience of where common problem arise. It should use abnormal input to check that they are properly processed and do not crash there. Actually, the unit testing, we don't do really the second part. But actually, if you have experience, if you know the system fully, if it depends on your experience, I think you could really test the program now thoroughly to make sure that it works in the normal way, everything is okay, normal operation, it works okay, and you try to break the system to see how long it takes to bring it up. In other words, the first test, you put the normal or the correct parameter, everything it runs okay, normal operation no matter what. And then the other type of testing, no, you put something abnormal input to try to see if the problem, if the program is really could give you the right information, what's wrong with that. And this takes me back to what really we used to talk about, the testing or whatever, when we used to say garbage in, garbage out. Garbage in, garbage out, this is in the good old days, of the computer. If tell you the computer or the program, if you give it a garbage, it will give you a garbage. Actually, late 80s, we changed this one to garbage in, information out. Program, if you give it a garbage, it should give you information out. Give you information about that garbage. What's wrong with that parameter? What's wrong with the parameter you gave me? Not just give you a garbage. Not the program just blew up because the parameter is not correct. Well, you have to have some strategies for testing, Well, if a field, it's a numeric field, you don't really check all the values of that field, from 0 to zillions or whatever. I think you partition the test. You check, a numeric value less than 0, like negative, 0, greater than 0. So in this case, you partition it to 3 partitions: negative, 0, greater than 0, which is positive, negative, and 0. Partition testing, where you identify groups of input that have common characteristic and should be processed in the same way. You should choose tests from within each of these groups. Or guideline-based testing, where you use testing guidelines to choose test cases. These guidelines reflect previous experience. Guideline probably be a previous experience of yours or somebody else, of the kind of errors that programmers often make when developing component. With experience, when you write a lot of programs, I think you will remember some of the programs will really give you a hard time a couple of years ago or a few years ago, whatever, when you have a problem with that program, whatever. So you are not gonna do it again. So you always really be aware of this type of errors and defect. Partition testing, input data and output result often fall into different classes where all members of the class are related. Each of these classes is an equivalence partition, or domain, which is domain. Like the example we talk about, negative numbers, positive numbers, or 0, where the program behaves in an equivalent way for each class. Like greater than 10,000, less than 10,000, or between 0 and 5,000, 5,000 and 10,000, etc. The test classes should be chosen from each partition. So in this equivalence, all these, this oval, or it shows some of the equivalence, input equivalence partition. We have 4 of them here, there. Partition, domain, or whatever, and the output, you expect it again into partition there, either or. So possible input, correct output, possible output, whatever you get it, what's the correct and what is really the possible things it's in. Equivalence partition, again, here equivalence partition, it's like, if you have a number, you try to check, less than 4, probably you check 3, check 4, 4 between 4 and 10, 10 and greater than 10. So you don't really do a test case for 3, 4, 5, 6, 7, 8, 9, 10, 11. No, you do 2, 3 of them, whatever. Again, for less than 10,000, so you check 999. Greater than 99999, so you do 100,000. And 50,000, which is in the middle between 1 and 100,000, whatever. Well, test guidelines here. Test software with the sequence which have only a single value. Use sequences of different size in different tests. Derive tests so that the first, middle, and last member of the sequence are accessed. Test with the sequence with sequence of 0 length or whatever, All these, guidelines that comes in your experience. When you have experience, when you write program after program after program, you gain a lot of experience, and really you could always you test your program with those guidelines in your mind. Also, guidelines, you choose input that force the system to generate all errors. Design input that cause input buffer to overflow. Repeat the same input or series of input numerous times. Force invalid output to be generated. Force computation result to be too large or too small, whatever. As we said, these guidelines, it comes with your experience. Component testing. Software components are often composite components that are made up of several interacting objects. So we are done with the unit testing, as we said, that just the unique unit, and now we have to integrate unit with unit. to come up with module, program with program, until we get a subsystem. And even subsystem with subsystem, it comes under integration testing. We found, in the unit testing, some of the defects, some of the problems we have there. Now we want to see the interfaces. So the emphasis here of the component testing and the interface. Because sometimes you find your program working okay, my program working okay. When we try to put them together, then they will suffer. The performance will suffer, So there is a problem in the interface. For example, in the weather station, the configuration component include objects that deal with each aspect of the reconfiguration. So software component of a composite component, as we said, and we have to test them together. You access the functionality of this object through the defined component interface. Testing composite component should therefore focus on showing that the component interface behaves according to its specification. So we concentrate here in the interface between the component, because each component we run the unit test and everything is okay. You can assume that the unit test and the individual object with the component have been completed and done correctly. Well, the interface testing, actually, like you have an A and B and C, and you see, we test A, we test B, we test C independently, and now we're going to test them, We let A call B, B return something to C, A call C, and B call C, and whatever, all these kind of things, which it is the interface between all these components. Well, if we understand, what's the relation between this component, A and B, and that's why we said, the unit testing is done by you as a programmer. But the software engineer who knows about the system, who knows the system thoroughly, he understands the relation between these components of the system, he's the one who could really do the interface, because he knows what is the relation between that system and that, and the other, while this program and that program. The tell you objectives are to detect fault due to interface errors or invalid assumption about interfaces. Well, the type, we check for parameter interface. Data passed from one method to a procedure to another, or procedure to another. Shared memory interface. Block of memory is shared between procedure or function. See, for like a global attribute or whatever, all these. Procedural interface. Subsystem encapsulate a set of procedure to be called by other. Message passing interface. Subsystem requests services from other. So we send a message or return a message. We send a parameter, it returns back a message or whatever. That's why, that's the type of testing, for. Well, some errors here, interface misuse. A calling component calls another component and makes an error in its use of its interface parameter in the wrong order. You send them, instead of sending A, B, C, you send it like an ACB in the wrong order, Interface misunderstanding. Calling component embeds assumption about the behavior of the called component which are incorrect. Since you don't know about the other component, you assume this is supposed to do so and so. Timing error. The called and calling component operate at different speed, and out of date information is accessed. Interface testing is guideline. There are some guidelines here. They tell you here, design tests so that the parameter to a called procedure are the extreme end of their range. Which is, the parameter, as really we did in the unit testing, we put the extreme range of that value of that attribute. Always test pointer parameters with a null pointer. Well, if there is a component called enter component, and they send a pointer, send a null value for a null pointer. Design test which cause the component to fail, the same as we did in the unit testing. Use stress testing in a message passing system. Try to send tons of messages, tons of call to that component to see how will it really react. In shared memory system, vary the order in which components are activated. Again, the guidelines for unit testing, interface testing, black box testing, whatever, It comes with experience. So we did so far the unit testing. It is done by programmer. You have test cases. It comes with that document. We call it probably like a defect testing to find out the defect, the calculation is correct, whatever. Then we are done with the unit testing. Then we went there and we did the component testing. Component testing, we tested mainly the emphasis here on the interface between these components. And we said, unit مع unit, module with module, subsystem with subsystem, all these are integration testing. Now the system is complete, all the components together now so we do a system testing. System testing during development involve integrating component to create a version of the system and then testing the integrated system, the whole system. The focus on system testing is testing the interaction between components. Well, here he screwed up again, the author. Well, it's not really interaction testing. The system now is we did the interaction or interface between these components. We did the interface. Now we reached the whole system. So the emphasis here and the non-function requirement, the emergent properties of the system. Is the system fast? Is the system secure? Is the system whatever? System test check that components are compatible, interact correctly, and transfer the right data at the right times across their interfaces. System testing tests the emergent behavior of the system, which it is the last one, really the most important thing in system testing, because most of these compatibility between components or whatever, we test them actually in the interface, in the component testing. Then one he called it component, which is integrated testing. System and component testing. During system testing, reusable components that have been separately developed and off-the-shelf system may be integrated with a new development component. The complete system is then tested. Well, this is an idea, or this is an opinion, but under opinion, probably we test it in the integration testing, as we said. If we develop from scratch 60-70% of the system, we bought 30%. I think we integrate them together to see if they are really compatible. So if we bought something off the shelf, it is already done by some company or whatever, I think probably the time of it in the component, but according to the author, he put it here in the system testing. Component developed by different teams member or sub-team may be integrated at this stage. System testing is a collective rather than an individual process. In some companies, system testing may involve a separate testing team. That's why here we talk about it. Because actually in the component testing, we said not the programmer who's writing it, it's another team. In the system testing, we have really to have a team to understand thoroughly and fully the whole system, relation between them, what's going on and whatever, in order to do the system testing. In some companies, system testing may involve a separate testing team with no involvement from designer and programmers. Use case testing. The use case developed to identify system interaction can be used as a basis for system testing. Each use case usually involves several system components, so testing the use case forces this interaction to occur. The sequence diagram associated with the use case document the component and interaction that are being tested. Well, actually, we did, and somehow, we don't want to confuse ourselves with a lot of type of testing. As we said, we have unit testing, integration testing, user testing, system testing, and probably the user acceptance testing is the last one, the one we're going to cover it in the next lecture. But use case testing, those the test cases. The test case, what really you're going to do, with that, like a sequence diagram, it is in the component testing. Because sequence diagram, you test like, you know, a thread, a scenario, which is involved probably 2-3 objects. The relation between this object or this program and the other program, and return something, etc. All these kind of things, you know, we do it here in the use case. One example of the use case or sequence diagram, which it is really actually, as we said, it is really an component testing, because we have many objects here. We have the weather data, we have the communication link, we have weather station, whatever. And we did really this, the weather information, request a report. Then they acknowledge that, yes, okay, we'll send it to you whenever ready. Then they send a report, you know, to the weather station. The weather station, again, acknowledge that they will send it back. Then we go to summarize, you know, the information from the communication link, go to the weather data, get, you know, the information from those instruments, from the parameter, thermometer, anemometer, all these kind of things. They collect them, summarize them, and send them back, you know, to the communication. And the communication acknowledge that, hey, I get them, like the satellite or whatever, and send it, reply it back to the weather information system with the report. And then the weather information system acknowledge that to the communication, that everything is okay, and that's it, close the issue here. Well, testing policy tell you here, exhaustive system testing is impossible. On a system testing, exhaustive one, we couldn't do it. I believe we do it probably in the unit. So testing policies which define the required system testing coverage may be developed. Example of testing policies: all system functions that are accessed through a menu should be tested. Combination of functions that are accessed through the same menu must be tested. Where user input is provided, all functions must be tested with both correct and incorrect input. Again, they repeat themselves with them. By now, we are done with this lecture. But before we go to the third lecture, there are two different types, especially in the software engineering, you know, testing, which it is very important, one, to understand and to know what is it, you know, as a software engineer. We have a type, we call it black box testing and white box testing. In other words, we look at the object in front of us as a unit, or as integrated testing, or as system testing in two different ways. We could test it as a black box testing. Black box testing, that you look at the program with no previous knowledge. You don't know anything about it. You are not the one who wrote the system. You are not the one. So in black box testing, a tester does not have any information about the internal working of the software system. You look at it as a black box. And that's why, you know, we look at black box. That's why they call it a black box. It is something you don't know anything about, and you test it to see if you develop a test case to test that program to see if really it passed that one or not. Black box testing is a high level of testing that focuses on the behavior of the software. It will involve testing from an external or an end user perspective. It is a type of testing can be applied to almost every type of test we talk about. Unit, integration, system, acceptance testing, all these things. The other type, which it is a white box testing. In other words, you look at the program, it's like really in a glass. It's a white box. It's transparent. You look at it and you see the logic of the program. This means you are the one who wrote, you are the one who designed the program, and you try to test the program against like your knowledge about it, you know. But the other one, the black box, you have no previous knowledge at all. White box testing is a testing technique which checks the internal functioning of the system. Testing is based on a coverage of code statement, path of or condition. The condition, the path, the logic of it, you know. This type of test is considered as a low-level testing. It is called a glass box, transparent box, clear box, or code-based testing. There are many different names to it. The white box testing method assumes that the path of the logic in a unit or program is known. You are the one who wrote the program, you are the one who designed it, you know the logic of it, and you test it. So these two concepts, they are important, logic to know as a software engineer. The black box testing, you look at the program as really, you have no previous idea about it. White box testing, it's like you look at it through a glass. You see it transparent and you see all the logic and you test it accordingly. By now we cover and we finish with lecture 2, and we have another lecture, the final lecture in system testing. Thank you and see you later.